what we're going to do now is look at parallel lines, and we're going to look at three different things that happen with parallel lines. They're corresponding, alternate, and co-interior angles. Now, you should have looked at these in year 7 to 9, but it just may be a revision of what we're going to do. So we're going to learn how to calculate angles with parallel lines. That's essentially what we have. And we have a transversal, which is just, I'll do a quick demonstration. There's parallel lines. Transversal's this guy here. So it's the one that crosses. So that's what it means, okay? All right, so we're going to look at this in class, but here is the question. So there's three different main types of parallel lines. The first one is alternate. Alternate angles, okay? Now, in parallel lines, alternate angles are equal, all right? Now, we often, in textbooks, we often see them as a Z, because what happens is that, I'll mark it out here, this angle, I'll put it as an asterisk, is equal to this angle here. All right, so that angle is equal to that angle. What's also true, and I'll do this in a different color, is that if we do a backward Z like that, I'm going to do asterisks again, but in a different color, this angle is equal to this angle. All right, so we can write alternate angles are equal in parallel lines. Now we've got a symbol for parallel lines. It's just this, all right? Not the brackets, just that. So maybe I'll take the brackets off. So I'll take the brackets off. So it's just that, simply like that, okay? Now the second form that we'll see in this is corresponding. Angles, okay? And normally they form like an F kind of shape, like this, all right? So what that means, and I'll put it in asterisks as well, is that this angle corresponds with this angle and they're equal as well. But notice that, I'm going to use a different color, that this angle, so I'm talking about the angles there, that this angle and this angle are the same angle in the, just they've moved up one or moved down one depending how you look at it, okay? Now what's also true is that if you do a backwards F, it's also true the case. So I'm going to also do like a purple asterisk. So that angle is equal to that angle, all right? So what can we say about corresponding angles? Corresponding angles, and this is a symbol for angles, by the way, are also equal in parallel lines. Okay, so I use my symbol there, but it just means parallel like here. So that means parallel. Okay, there's one last one that we're looking at, and that is co-interior angles, okay? And they form like a C, okay? So I'll put that asterisk there. That angle is, no, it's not equal to that. I'm going to change the symbols a bit. I'm going to change it to a star, okay? And because they're not equal, but they add up to 180. They add up to 180 degrees. So for example, if this was 50 degrees in there, then I have to add something to equal 180, then this will have to be 130 degrees because 130 plus 50 is 180, okay? So both those angles, so if we want to look at it in the symbol, it'll be star plus asterisk must equal 180 degrees, okay? Now I'm going to rub some of that information off because it looks pretty busy. Now what's also true is that we can do a backwards C, and what that means, and I'm going to use the same colors as I had before, is that if this is star angle and this is asterisk, okay, they also add up to 180 degrees. So alternate angles are equal in parallel lines, add up to 180 degrees in parallel lines, okay? Corresponding angles are equal with parallel lines, and co-interior, they're like inside, they will add up to 180 degrees. Okay, what we're going to do is we're going to do this example and then we're done, all right? So I'm going to do this example in blue, okay? So we want to find all these pronumerals, okay? The first one I want to find is, because that's 50 degrees, that's going to be 50 degrees, and what is our explanation? It will be this one, alternate angles. Actually, no, corresponding angles, okay? See how it makes the F kind of shape? See, this angle here is the same as that angle there. So this is how we're going to write it. Alpha equals 50 degrees, and we always need a reasoning. And in brackets, I'm going to go corresponding angles, parallel lines. Okay, so that's explanation. Now, what happens in a normal test is that you'll get a mark for the correct answer and you'll get a second mark for the explanation. You will lose marks if you haven't explained it yourself. All right, let's do beta. And yeah, so beta equals, so that's that one here. That looks like a Z to me, so let's do the highlighter from here, there. So yes. So that is, that's alternate, okay? So it's going to be the same as well. So 50 degrees, and that's alternate angles in parallel lines. If you're confused, look at the previous slide. See how it looks like the purple ones that we did here, okay? The purple ones that we did here. So that's the explanation there. And once again, you get 1 mark for the answer, 1 mark for the explanation. So the explanation is critical. That's why this topic is called reasoning in algebra. Now, the last one I want to look at is this one here. It's called gamma. Now, gamma we don't know the answer of, but I know it looks like co-interior. And I know that 50 plus gamma will equal 180 degrees. So I'm going to write that out. 50 plus gamma equals 180 degrees. Now my explanation for that is, and that will not be correct mathematically if I did, is that co-interior angles add up to 180 degrees parallel lines, okay? Now I can work out what gamma is. Gamma will equal 130 degrees, okay? Because what I've done is I've minus 50 degrees from here, and I have to minus 50 degrees from here to find out what gamma is by itself, and it's 130 degrees. Now there's one more there that I haven't talked about that we still need to find the answer, and that's delta, okay? So I haven't actually given you the tools to find out, but I'm just going to go delta equals 50 degrees. Now this is, the reasoning has got none of these three. It's one that you should know from previous years, but that's why we'll put it in the example. If we've got this and this, these straight lines, the opposite angles, so this angle and that angle will always be equal, and that's called vertically opposite. Vertically opposite angles are equal, okay? So that's the explanation. So that's what I'm going to write here. Vertically, and I'm just going to go op, angles, and that's my explanation. So always show your reasoning. Anyway, that's the end of the lesson. Peace out.